Okay, I don't know if I mentioned it, but this is probably my favorite section in the whole course. So now we're going to use that one-to-one property to solve some other exponential equations. So we have an example here, and we say have 8 to the x plus 2, 16 to the x plus 1, and you might be saying, well, you can't use the one-to-one property because the bases aren't the same. But wait, we know that 8 is equal to 2 cubed, and we know 16 is equal to 2 to the 4th. So what we're going to do is we're going to replace that 8 with 2 cubed, and we're going to replace the 16 with 2 to the 4th. Okay, now, what do we do when we have a power raised to another power? Well, we multiply those. And so we're going to have 2 to the 3x plus 6 equals 2 to the 4x plus 4. I went ahead and did the distributing here. So, okay, now the bases are the same, and we can set those exponents. So we're just popping out those exponents. We're not dividing anything. We're not taking a root or anything. We're just popping out those exponents. We're saying if this equals this and the bases are the same, then the exponents have to be the same. Okay, so there we go. We can subtract 3x from both sides. This is linear. We get x plus 4, subtract the 4 from both sides. And we get 2 equals x, or x equals 2. Okay, so we have solved. We're trying to get the value of x that will work. You can check it, but we get x equals 2. All right, so here's another example. We have 2 to the 5x, and then you might be worried about that radical. Well, we can write the square root of 2 as 2 to the 1/2, and then it will be a base with an exponent. So 2 to the 5x, I don't know why I wrote that so high, equals 2 to the 1/2. Well, now the bases are the same, so you can pop out those exponents and set them equal to each other. 5x equals 1/2. So how will we solve this? Well, I would multiply by 1/5 on both sides because of the fractions. You're dividing by 5, but it might be easier to write it that way. And we get x equals 1 over 10. And we have solved it. Okay.